The topic of this video is ANOVA, Degrees of Freedom, and the F statistic. The General Social Survey is an annual survey given to a random selection of about 1,500 adults in the United States. Among the many questions asked are, what is the highest level of education you have completed? And if you are employed full-time, how many hours do you spend working at your job during a typical week? In a recent year, 1,125 respondents answered both questions. The summary statistics are given in the chart below. The sample data consist of the times in hours per week and were given by the respondents. The table provided states the following. There are 4 columns. First one represents groups, which are less than high school, bachelor's, and graduate. Second column represents sample size. First sample size is 299, next 293, next 274, and last one is 259. Third column is called sample mean. First mean is 41.4, next 42.6, next 41.2, and last one is 42.3. Final column represents sample variance for each particular group, and variances are 90.5, 99.3, 114.6, 111.4. To decide if there are any differences in the mean hours per week worked by these different groups, we can perform a one-way independent samples ANOVA test. Such a test uses the statistic F, which is found by a ratio of variation between the samples and variation within the samples. For the data from the survey, assume that F is approximately equal to 1 and 27/100th. In first part, we need to find the numerator degrees of freedom for this F statistic. Numerator's degree of freedom is found by taking the number of populations sampled. We typically label that by K and subtracting 1. So degree of freedom right here would be K minus 1, or 4 groups, less than high school, bachelor's, and graduate, minus 1. So degree of freedom is 3. Second part, give the denominator degree of freedom for this F statistic. The denominator degree of freedom is defined as uppercase N minus K, where N represents the total number of all data entries. If we add all sample sizes, we should get 1,125 respondents. That means that my uppercase N is 1,125, and K is the number of populations sampled, which is 4. The difference between these two numbers yields 1,121 as the denominator's degree of freedom. Now we have one more part of the question to answer. For the survey data, can we conclude that at least one of the groups differs significantly from the others in mean hours worked in a typical week? Use 10% level of significance. To answer this question, we need to come back to the idea of the hypothesis statement. We need to understand what the null and alternative hypotheses for ANOVA tests typically are saying. For ANOVA test, null hypothesis is always going to claim that the means of all 4 populations are same. Mu sub 1 is equal to mu sub 2 is equal to mu sub 3 is equal to mu sub 4. Alternative statement will say no, at least one of those means is different from the rest. Maybe more than one is different. So these are typical statements for hypotheses for the ANOVA test. Please notice that our question is asking Can we conclude that at least one of the groups differs significantly? In other words, can we reject the null hypothesis? How can we decide whether to reject or keep the null hypothesis? Well, one thing we know is the F statistic. F statistic is given to be a 1.27. If I knew the critical value, I could compare F statistic to the critical value and make a decision whether to reject or keep the null hypothesis. Let's get that critical value. With 10% level of significance, I can draw this diagram with 10% of area to the right side, that's my critical region, and some mystery point, I'm going to call it X because that's how my calculator going to show it to me, separates 10% from 90%. I'm using the same strategy that I demonstrated in the video explaining how to work with F curves. I use the Numeric Solver to solve the following equation. I say that function f(CDF) with interval defined by lower bound of 0 and upper bound of x, so between 0 and x, this interval should contain 90% of data, here it is, with the given degrees of freedom, which we just found to be 3 and 1121. When I enter this into Numeric Solver and go through the process properly, the answer comes out to be 2.089 when rounded to 3 decimal places. It means that this location here, right there, is 2.089. I am given a test statistic F to be approximately 1.27. I hope you agree that 1.27 is on the left side of this critical value I just found, somewhere here maybe. 1.27. It is safely in the acceptance region, therefore we do not have enough evidence against null hypothesis and we keep the null hypothesis, we cannot reject it. My answer to part C will be, can we conclude that at least one of the groups differs significantly from the others in mean hours worked? Well, not really, because I kept the null hypothesis, which claimed that means are approximately equal. Well, they're not like ideally equal, but there's no significant difference really. That's what it means. And my answer to the question will be no, I cannot conclude that at least one of the means is different. I would like to point out that we just answered this question and made a decision about the statements in our null and alternative hypotheses based on the critical value method, because we computed a critical value corresponding to 10% significance level and then compared critical value to the test statistic F given to us. We can answer this question also using p-value method, and that's the next thing I would like to quickly demonstrate to you. The p-value method is not involving the critical value. Therefore, you don't have to compute critical value if you prefer this method. What is important in this method is to find the area to the right of the F statistic of 1.27. Why to the right? Because it is a right-tailed test. Somewhere on this number line called F scale, this is F scale, there are F scores in here, there is 1.27, and I would like to know how much area to the right of it is. I can only guess where 1.27 should be, maybe like there. It's very hard to tell precisely because degrees of freedom for every different distribution will give you slightly different results. It depends on the degree of freedom. So I'm just guesstimating where 1.27 will be. I would like to know how much area to the right of this point there is under this curve. To find the answer, I'm using the f(CDF) function with interval from 1.27 to positive infinity with 3 numerator degrees of freedom and 1121 denominator's degree of freedom. And when I input this into my calculator, it produces 0.2833. It means that the p-value is 0.2833. P-value, being so big in comparison to the significance level, tells me not to reject null hypothesis, and therefore I am keeping the statement that the means are equal, which was exactly the same result we obtained using critical value. We did not reject null hypothesis, and therefore we cannot conclude that at least one group differs from other groups in the mean hours worked.